day, I'm Jera Kisnar Abanidia from Group 5 and I will be discussing spot speed study. Speed study purposes. Establishing speed zone of new or existing speed limit or enforcement practices. Dito natin nalalaman yung pagpapatupad sa mga bagong lugar kung saan may mga speed limit. Ine-determine niya din yung speeds at the problem location to validate whether speeds are too high. For traffic operation and control, na-establish niya din yung mga lugar na may mga curve. Example na nito yung nandun sa Baguio. Establishing speed trends at local, state, and national level to assess effectiveness of speed limit policy. It is an important transportation consideration because it relates to safe, time, comfort, convenience, and economics. Kaalaman natin sa speed kapag tayo bumabahe ay importante dahil dito natin nako-consider yung kaligtasan at yung oras natin kapag tayo ay aalis. Spot speed studies are used to determine the speed distribution of stream at a specific location used to describe the quality of journey and the performance of road network in accommodating traffic demand. Dito sa spot speed study, nalalaman natin kung ang speed ay nadidistribute sa tama sa pag-agos ng traffic sa highway. Kung na-observe din natin ang speed, nade-determine ang roadway kung kailangan ng mga reconstruction, realignment, at bagong batas sa enforcement. Naman natin kapag Monday, sobrang traffic pagpapasok tayo sa mga trabaho sa school. At kapag Friday, peak period ito ng madaming sasakyan na nag-uwian. Kaya dapat daw i-conduct ang spot speed study tuwing Tuesday, Wednesday, at Thursday. Dahil ang kailangan lang na sample size at least 50 to 100 vehicle. Sa spot speed data, nag-gather natin siya gamit ang 3 methods. Ang stopwatch method daw, yun yung pinakamura at least accurate na method. Speed percentiles and how to use them. Most important to understand are the 50th and the 85th percentiles. The 50th percentile is the median speed of the observed dataset. This percentile represents the speed at which half of the observed vehicles are below and half of the observed vehicles are above. The 50th percentile of speed represents the average speed of the traffic stream. The 85th percentile is the speed at which 85% of the observed vehicles are traveling at or below. This percentile is used in evaluating, recommending posted speed limits based on the assumption that 85% of the drivers are traveling at a speed they perceive to be safe. In other words, the 85th percentile of speed is normally assumed to be highest safe speed for a roadway section. Weather condition may affect speed percentiles. For example, observed speeds may be slower in a rainy or snowy condition. Frequency distribution table. Dito natin masosolve ang speed percentile. Ang frequency of vehicle sa column 2 ay yung mga number ng sasakyan na recorded, then ang bilis nito in meter per hour sa column 1. Ang cumulative frequency naman sa column 3 ay yung pag-add together row by row ng frequency of vehicle. At lastly, dun sa fourth row is a running percentage of the cumulative frequency. Calculating speed percentile. SD is equal to PD minus Pmin divided by Pmax minus Pmin multiplied by Smax minus Smin plus Smin. SD is equal to speed at PD percentile desired. Pmax is higher cumulative percent, Pmin is lower cumulative percent, Smax is higher speed, and Smin is lower speed. For calculating speed percentile, where speed is equal to percentile desired minus lower cumulative percent divided by higher cumulative percent minus lower cumulative percent multiplied by higher speed minus lower speed plus lower speed ulit. Percentile, gagamitin natin ang frequency distribution table. Ang 50th percentile speed is equal to 50%. Nag-fall siya between sa 27 and 30 meter per hour. So, ang higher cumulative percent is equal to 30 meter per hour. And lower cumulative percent is equal to 23%. Therefore, to find speed at percentile desired na equal sa 50%. To to 50% minus 23% divided by 54% minus 23% multiplied by 30 meter per hour minus 27 meter per hour plus 27 meter per hour. It is equal to 29.6 meter per hour. Percentile speed, it falls between 33 at 36 meter per hour. So, ang higher speed natin is equal to 36 meter per hour. Ang lower speed naman is equal to 33 meter per hour. The higher cumulative percent is equal to 86% and the lower cumulative percent is 72%. To find speed at percentile desired in this case, speed is equal to 85% minus 72% divided by 86% minus 72% multiplied by 36 meter per hour minus 33 meter per hour plus 33 meter per hour. It is equal to 35.8 meter per hour. Being successful para makomplete ang spot speed study gamit ang small sample size sa maikling oras. Ang stopwatch method ay isang mabilis at murang method sa pag-collect ng speed data. Tayo to a stopwatch spot speed study. Una dito yung pag-obtain ng appropriate study length. Number 2, select proper location and layout. 3. Record observations on stopwatch spot speed study data form. 4. Calculate vehicle speeds. 5. Generate frequency distribution table and determine speed percentiles. Meron ding spot speed study steps na kailangan nating sundin. Una dito yung pag-organize ng study plan. 2. Select data collection method. 3. Select appropriate site and collect field data. 4. Reduce and analyze data. 5. Interpret and report findings. Ng spot speed study, kailangan natin ng stopwatch at checklist. Ito ay example ng checklist na kailangan natin sundin yung mga step nila. Una dito yung pag-obtain ng stopwatch, backup stopwatch, obtain 50 to 100 foot tape, pag-obtain ng data collection form, obtain hard hat and safety vest, obtain brightly colored reference post, pag-select ng time and day, pag-contact sa law enforcement. Sa pag-obtain naman ng appropriate study length, the study length is important because it is used in the calculation of vehicle speeds. Table 2.3 nagpro-provide dito ng recommended study lengths which are based on the average speed of traffic stream. Using this recommended study length makes speed calculation straightforward and less confusing. If these lengths are not appropriate, another length can be used assuming it is long enough for reliable observer reaction time. Kailangan natin malaman ng study length sa pag-calculate ng bilis ng sasakyan. Dito sa may table, nakabase ito sa may average speed ng pagdaloy ng traffic. Traffic stream average speed, recommended study length in feet. Below 25 meter per hour, it is calculated 88 feet. 25 to 40 meter per hour, 176 feet. Above 40 meter per hour, 264 feet. Proper location. Figure 2.1, sa pag-select daw ng proper location and layout, kailangan nakikita ng malinaw na observer ang kahit ano na vertical reference post. Ang observer din daw ay kailangan nakaposisyon siya sa may tulay o kaya sa roadway, back slope. Nag-i-start ang time sa brightly colored observer post at nag-i-end ito sa may tree o sa signpost na observer sightline. Sa pag-record naman ng observations on stopwatch spot speed data form, kailangan i-record daw yung date, location, posted speed limit, weather condition, start time, end time, and downtime. Pag umandar na ang isang sasakyan at lumampas na siya sa may mark, dito na malalaman ang study length. At dito na din mag-end ang stopwatch kapag lumampas na yung gulong niya sa may reference post sa harap ng observer. Calculate natin ng vehicle speed. Use the predetermined study length and the elapsed time it took the vehicle to move through the course as recorded in the stopwatch data form. Ang formula niya is equal to V is equal to D divided by 1.47 T, where V is equal to spot speed in meter per hour, D is equal to length, is measured in feet, and T is elapsed time in seconds. In the equation, 1.47 is a constant that converts units of feet per second into miles per hour. For example, if the spot speed study length is 100 feet and the motorist elapsed time is 2.5 seconds, the motorist is traveling at 100 feet divided by 1.47 multiplied by 2.5 seconds, it is equal to 27 meter per hour. Stopwatch spot speed data form. The city of Cottonwood Glen received a complaint of afternoon traffic speeding in a residential area. The city suspected this was related to students leaving a nearby high school. The first action taken by the city was to quantify the facts by conducting a spot speed study. The city decided to use the stopwatch method because of their limited resources. A location was selected near the intersection of 4th Street and University Avenue, approximately 2 blocks from the high school and where the city had received multiple speeding complaints from residents. The posted speed limit is 30 meter per hour. The study was conducted on a Wednesday and started at 3 p.m. The time was selected to correspond to the period when most high school students leave the school. The study continued until a sample size of 100 vehicles was measured. The study length of 176 feet was used because the posted speed limit is between 25 and 40 meter per hour, as shown in the table. The study layout is illustrated also in figure 2.2. Sample ng spot speed study layout. Ang vertical reference post, dito yung beginning timing. At yung sa stop timing naman yan, yung sa may puno, ang reference point. Sa vertical reference point, mas natutulungan niya ang observer para maging mas accurate ang timing ng line of sight. The study shows that the 50th percentile or median speed falls between 27.2 and 28.9 meter per hour, and the ATP percentile speed falls between 33.3 and 35.2 meter per hour. In equation 2.1, it is used to find the exact speeds for the 50th and ATP percentile of speed. Natin ang exact speed ng 50th percentile. Ang speed is equal to 50%. Ang higher speed is equal to 54%. Lower cumulative percent is equal to 41%. Higher speed is 28.9 meter per hour and lower speed is 27.2 meter per hour. So, ang computation ng speed is equal to 50% minus 41% divided by 54% minus 41% multiplied by 28.9 meter per hour minus 27.2 meter per hour plus 27.2 meter per hour. The final answer is 28.4 meter per hour. Ng ATP percentile speed, ang given natin is speed is 85%, higher speed is 92%, lower cumulative percent is 83%, higher speed is 35.2 meter per hour, and lower speed is 33.3 meter per hour. Ang solution natin is speed is equal to 85% minus 83% divided by 92% minus 83% multiplied by 35.2 meter per hour minus 33.3 meter per hour plus 33.3 meter per hour. Final answer natin is 33.7 meter per hour. Ito sa may figure 2.3, ito ang example ng stopwatch spot speed data form. Naka-record dito kung ilang passenger ang bawat sasakyan sa buses and trucks. Sa distribution table, nakuha natin ang sagot nito galing dun sa study data form. Ito sa may fourth column, cumulative percent, ito yung running percentage ng cumulative frequency. Is sometimes used to determine whether the ATP percentile speed is too high compared to the speed limit. Kapag daw ang ATP percentile niya is 5 meter pataas sa nakapost sa speed limit, kailangan evaluate ito. Sa case nito, ang ATP percentile ng speed is equal to 3.4 meter per hour above the speed limit. So, ang speed natin ay hindi issue dito.
Good day everyone, I'm Heidi Adeline S. Centenarial from Group 5. I will discuss your radar meter method. Sabi dito, yung karaniwang ginagamit daw na aparato para sa direktang pagsukat ng bilis. Ang mabisang distansya sa pagsukat para sa mga metro ng radar ay umaabot sa 200 talampakan hanggang sa 2 milya. Ang radar meter daw ay nangangailangan ng line of sight upang ma-accurate na masukat yung bilis at madaling i-operate ng isang tao. Radar meter spot speed study preparation checklist. When preparing for spot speed study using a radar meter, use the checklist in table 2.5. The checklist may be modified or expanded as necessary. Table 2.5 radar meter spot speed study preparation checklist. Ito yung example ng radar meter spot speed study preparation checklist. Step: obtain radar meter. Read instruction and safety direction for the radar meter. Obtain backup battery. Obtain tripod to support radar meter. Create data collection forms. Obtain hard hat and safety vest. Select time and day. Contact local law enforcement and others. Key steps to a radar meter spot speed study. A radar meter spot speed study includes 4 key steps. 1. Select proper location and placement of radar meter. 2. Determine an appropriate selection strategy. 3. Record observation on radar meter spot speed study data form. 4. Generate frequency distribution table and determine speed percentiles. Select proper location and placement of radar meter. Ang pagpaposisyon daw ng radar unit ay determine ng mga kakayahan ng radar unit. Ang unit ay dapat ding nakakonceal from the view of motorists. Sabi dito, yung effective ranges daw may be up hanggang 2 milya, habang yung distance naman daw ay nagdaragdag ng pagbaba ng pagiging epektibo. Ang hindi gaanong accurate na posisyon na madalas na nagre-resulta sa hindi pagbasa ng isang device daw ay nakukuha kapag ang metro ay nakatuon sa 90-degree angle to the roadway center line. Determine an appropriate selection strategy. Sabi dito, except daw sa mga pag-aaral na isinasagawa sa ilalim ng mga kondisyong mababa ang lakas ng tunog, imposibleng makakuha ng isang pagsukat ng radar para sa bawat sasakyan. Para sa peak flow analysis daw, yung ang mga bilis daw ay sinusukat during the peak period. For assessing general speed trend daw o para sa pagtatakda ng mga limitasyon sa bilis, mas appropriate daw ang mga pagsukat kapag off-peak. The selection of the target vehicle that represent the vehicle population under study is also important. The question is, what type or types of vehicle are of concern? Cars, trucks, buses, or others? Typically, cars, station wagons, pick-up, and panel trucks. And motorcycles are classified as passenger cars. Other trucks and buses and farm equipment may be recorded separately. When the target vehicle is defined, a selection strategy is developed to provide a random sample. A random sample will reduce the tendency to select the vehicles that stand out. For example, the observer could obtain a speed reading from every 4th vehicle or every 10th vehicle. Record observation on radar meter spot speed data form. On the radar meter spot speed data form, the observer records the date, location, posted speed limit, weather conditions, start time, end time, and downtime. Slash is recorded on the data form corresponding to speed observed for each selected vehicle, or only the lead vehicle in a group, under the appropriate vehicle type classifications. Generate frequency distribution table and determine speed percentiles are tools used to determine effective and adequate speed limits. The two speed percentiles most important to understand are the 50th and the 85th percentiles. 58th percentiles The 58th percentiles is the median speed of the observed dataset. Ang porsyento daw na ito ay ang kumakatawan sa bilis kung saan kalahati ng mga naobserbahan ay nasa ibaba at yung kalahati naman ay nasa itaas. Yung ika-50% ng bilis din daw ay nagre-represent sa average na bilis ng stream ng traffic. Yung 85th percentiles. The 85th percentiles is the speed at which 85% of the observed vehicles are traveling at or below. Ang porsyento din daw na ito ay ginagamit sa pagsusuri o pagrerekomenda ng naipost na mga limitasyon na bilis batay sa paglalagay ng 85% ng mga driver na naglalakbay sa isang bilis na sa palagay nila ay ligtas. Sa makatuwid daw, yung 85th percentile daw ay pinapalagay na pinakamataas na ligtas na bilis para sa isang roadway section. Ang mga kondisyon ng panahon ay maaaring makaapekto din daw sa bilis ng porsyento. For example, ang mga naoobserbahan na bilis ay maaaring mas mabagal sa maulan o manyebe ng mga kondisyon. Example, radar meter spot speed study. The city decided to conduct the study near the corner of 6th Street and Main Street, the intersection where a larger number of the crashes were occurring. The posted speed limit on Main Street is 35 mph. The study was conducted on a Thursday from 7 a.m. to 7:25 a.m. The time period was chosen to capture morning commutes to the local high school and to work. A sample size of 100 was recorded. The study layout is illustrated in figure 2.5. The observer used a tree to conceal the observation vehicle from the target vehicles. The results of the study are shown in figure 2.6 data form and table 2.6 distribution table. Ito yung example ng illustrated the study layout. Ito naman yung 2.6 data form table example at 2.6 distribution table example. The study shows the 58th percentile or median speed was between 34 and 35 mph and the 85th percentile of speed was between 40 and 41 mph. Equation 2.1 is used to find the exact speeds for the 50th percentile of speed and the 85th percentile of speed. For the 50th percentile of speed, PD is equals to 50%, P sub max is equals to 53%, P sub min is equals to 45%, S sub max is equals to 35 mph, and S sub min is equals to 34 mph. S sub D is equals to 50% minus 45% over 53% minus 45% times 35 mph minus 34 mph plus 34 mph is equals to 34.6 mph. For the 85th percentile of speed, P sub D is equals to 85%, P sub max is equals to 88%, P sub min is equals to 81%, S sub max is equals to 41 mph, and S sub min is equals to 40 mph. So, S sub D is equals to 85% minus 81% all over 88% minus 81% times 41 mph minus 40 mph plus 40 mph is equals to 40.6 mph. A 5 mph rule of thumb is sometimes used to determine whether the 85 percentile of speed is too high compared to the posted speed limit. If the 85th percentile of speed is 5 mph or more above the posted speed limit, the situation should be evaluated. In this case, the 85th percentile of speed was 5.6 mph above the posted speed limit. So, speeding may be an issue. This situation should be considered for further evaluation. The following actions may be considered. Adjust the posted speed limit. Increase speeding enforcement. Initiate traffic calming measures. Conduct public awareness and effort. Pneumatic road tube method. See figure 2.7 and are connected to recorders located at the side of the road. See figure 2.8. Ito yung mga example ng pneumatic road tubes and recorders. Sabi dito, yung pneumatic road tube method daw ay karaniwang ginagamit para sa mas matagal na mga oras na pagkolekta ng data kaysa sa paraan ng stopwatch o radar meter. Gamit din daw ito sa paglalagay ng tubo sa mga linya na konektado sa mga recorder na matatagpuan sa gilid ng kalsada. The automatic recorders are capable of storing large amounts of individual vehicle data or even larger amounts of vehicle classification data. The collected data are downloaded from the recorder to a laptop computer or portable floppy disk drive in the field or via telephone modem to a centrally located computer. Pneumatic road tube spot speed study preparation. Checklist when preparing for a spot speed study using pneumatic road tubes. Use the checklist in Table 2.7. The checklist may be modified or expanded as necessary. Table 2.7, Pneumatic road tube spot speed study preparation checklist. Ito yung example. Step, when complete, notes. Step, obtain equipment. Read user's manual. Obtain measuring tape for spacing tubes. Obtain software. Obtain scissors for trimming tubes. Select methods for attaching tubes to the roadways. Obtain recorders. Obtain new batteries for recorders. Obtain hard hat and safety vest. Select time and day. Select location. Involve corresponding jurisdiction to provide traffic control, and others. Key steps to a pneumatic road tube spot speed study. A pneumatic road tube spot speed study includes 4 key steps. 1. Perform necessary office preparation. 2. Deploy and calibrate data collection equipment. 3. Check data and retrieve equipment. 4. Generate frequency distribution table and determine speed percentiles. Yung perform necessary office preparation daw, for example, maaari ka makipagtulungan daw sa mga opisyal ng estado o lokal sa pagkuha ng kontrol sa trapiko para sa pag-deploy at pagbawi ng mga kagamitan. Yung mga pangkat daw ay dapat na may paliwanag yung proseso ng pagkolekta ng data upang matiyak na ang lahat ng mga taga-masid daw ay nakakakolekta ng parehong uring data. Deploy and calibrate data collection equipment. Sabi dito, yung tubo daw ng kalsada ay minimize kaya yung bawat traffic lane ay sarado. At pagkatapos din daw ilagay ng mga manggagawa ang mga tubo ng kalsada sa mga linya. Dapat daw yung location ng mga tubo ay dapat nasa labas upang maimpluwensyahan ng iba pang factors tulad ng isang intersection major access points. Ang paghihiwalay naman daw ng mga tubo ng pneumatic ay dapat nasa 2 o 15 talampakan. Para sa tamang spacing ng mga tubo ng pneumatic ay mag-refer sa manual ng mga ginagamit. Ang pagkontrol sa traffic ay dapat tumakbo ng maayos upang masecure ang mga tubo ng kalsada. Check data and retrieve equipment. Ang kawastuan daw ng isang kagamitan sa pagsukat ng mga bilis ng traffic stream ay dapat masuri. Sinusukat muna daw ng recorder ang lumipas na oras na aabutin ng sasakyan upang dumaan sa mga tubo. Pagkatapos, ang mga agwat daw na oras na ito ay na-convert sa kaukulang bilis ng lugar at ang mga lumilipas daw na oras ay maaaring suriin sa isang stopwatch. Maaaring ayusin din daw ng tauhan ang recorder hanggang maitala ang tamang bilis. May papayo daw na suriin ang pagpapaandar at wastong mga gamit nang hindi bababa ng 24 hours ng pagkolekta ng data. Kapag natapos na ang pagkolekta ng data, dapat suriin daw ulit ang naitala na data para sa kawastuan. Generate frequency distribution table and determine speed percentiles. Determine the 50th and 85th speed percentiles using a frequency distribution table and calculation as described earlier. Katulad lang din siya ng key step sa radar meter spot speed study.